Chapter 6 of The Story of Alchemy. This LibriVox recording is in the public domain. Recording by Peter Yearsley. The Story of Alchemy and the Beginnings of Chemistry by M. Pattison Muir. Chapter 6. Alchemy as an Experimental Art. A modern writer, Mr. A. E. Waite, in his Lives of the Alchemistical Philosophers, says, "The philosophical theory of transmutation is based on the composite character of the metals, on their generation in the bowels of the earth, and on the existence in nature of a pure and penetrating matter which, applied to any substance, exalts and perfects it after its own kind." It must be admitted that the alchemists could cite many instances of transmutations which seemed to lead to the conclusion that there is no difference of kind between the metals and other substances, such as water, acids, oils, resins, and wood. We are able to-day to effect a vast number of transformations wherein one substance is exchanged for another, or made to take the place of another. We can give fairly satisfactory descriptions of these changes, and by comparing them one with another, we are able to express their essential features in general terms which can be applied to each particular instance. The alchemists had no searching knowledge of what may be called the mechanism of such changes. They gave an explanation of them which we must call incorrect in the present state of our knowledge. But, as Oefer says in his Histoire de l'Alchimie, to jeer at the alchemical theory is to commit at once an anachronism and an injustice. Unless the world should finish to-morrow, no one can have the pretension to suppose that our contemporaries have said the last word of science, and nothing will remain for our descendants to discover, no errors for them to correct, no theories for them to set straight. What kind of experimental evidence could an alchemist furnish in support of his theory of transmutation? In answering this question, I cannot do better than give a condensed rendering of certain pages in Oefer's Histoire de l'Alchimie. The reader is supposed to be present at experiments conducted in the laboratory of a Grand Master of the sacred art in the 5th or 6th century. Experiment. Ordinary water is boiled in an open vessel. The water is changed to a vapour which disappears, and a white powdery earth remains in the vessel. Conclusion. Water is changed into earth and air. Did we not know that ordinary water holds certain substances in solution, and that boiling water acts on the vessel wherein it is boiled, we should have no objection to urge against this conclusion. It only remained to transmute fire, that the transformation of the four elements might be completed. Experiment. A piece of red-hot iron is placed in a bell jar filled with water, held over a basin containing water. The volume of the water decreases, and the air in the bell jar takes fire when a lighted taper is brought into it. Conclusion. Water is changed into fire. That interpretation was perfectly reasonable, at a time when the fact was unknown that water is composed of two gaseous substances, that one of these, oxygen, is absorbed by the iron, and the other, hydrogen, collects in the bell jar, and ignites when brought into contact with a flame. Experiment. Lead, or any other metal except gold or silver, is calcined in the air. The metal loses its characteristic properties, and is changed into a powdery substance, a kind of cinder or calx. When this cinder, which was said to be the result of the death of the metal, is heated in a crucible with some grains of wheat, one sees the metal revive, and resume its original form and properties. Conclusion. The metal which had been destroyed is revivified by the grains of wheat and the action of fire. Is this not to perform the miracle of the resurrection? No objection can be raised to this interpretation as long as we are ignorant of the phenomena of oxidation, and the reduction of oxides by means of carbon or organic substances rich in carbon, such as sugar, flour, seeds, etc. Grains of wheat were the symbol of life, and by extension of the resurrection and eternal life. Experiment. Ordinary lead is calcined in a cupel made of cinders or powdered bones. The lead is changed to a cinder, which disappears into the cupel, and a button of silver remains. Conclusion. The lead has vanished. What more natural than the conclusion that it has been transformed into silver? It was not known then that all specimens of lead contain more or less silver. Experiment. The vapour of arsenic bleaches copper. This fact gave rise to many allegories and enigmas concerning the means of transforming copper into silver. Sulphur, which acts on metals and changes many of them into black substances, was looked on as a very mysterious thing. It was with sulphur that the coagulation (solidification) of mercury was effected. Experiment. Mercury is allowed to fall in a fine rain onto melted sulphur. A black substance is produced. This black substance is heated in a closed vessel. It is volatilized and transformed into a beautiful red solid. One could scarcely suppose that the black and the red substances are identical if one did not know that they are composed of the same quantities of the same elements, sulphur and mercury. How greatly must this phenomenon have affected the imagination of the chemists of ancient times, always so ready to be affected by everything that seemed supernatural. Black and red were the symbols of darkness and light, of the evil and the good principle, and the union of these two principles represented the moral order. At a later time the idea helped to establish the alchemical doctrine that sulphur and mercury are the principles of all things. Experiment. Various organic substances by heating in a distillation apparatus. The products are, in each case, a solid residue, liquids which distil off, and certain spirits which are disengaged. The results support the ancient theory which asserted that earth, water, air, and fire are the four elements of the world. The solid residue represented earth, the liquid products of the distillation water, and the spirituous substances air. Fire was regarded sometimes as the means of purification, sometimes as the soul or invisible part of all substances. Experiment. A strong acid is poured onto copper. The metal is attacked and at last disappears, giving place to a green liquid as transparent as water. A thin sheet of iron is plunged into the liquid. The copper reappears and the iron vanishes. What more simple than to conclude that the iron has been transformed into copper? Had lead, silver, or gold been used in place of copper, one would have said that the iron was transformed into lead, silver, or gold. In their search for the pure and penetrating matter which applied to any substance exalts and perfects it after its own kind, the alchemists necessarily made many inventions, laid the foundation of many arts and manufactures, and discovered many facts of importance in the science of chemistry. The practitioners of the sacred art of Egypt must have been acquainted with many operations which we now class as belonging to applied chemistry. Witness their jewellery, pottery, dyes and pigments, bleaching, glass-making, working in metals and alloys, and their use of spices, essential oils, and soda in embalming and for other purposes. During the centuries when alchemy flourished, gunpowder was invented, the art of printing was established, the compass was brought into use, the art of painting and staining glass was begun and carried to perfection, paper was made from rags, practical metallurgy advanced by leaps and bounds, many new alloys of metal came into use, glass mirrors were manufactured, and considerable advances were made in practical medicine and sanitation. Basil Valentine, who was one of the greatest alchemists of the 16th century, discovered many of the properties of the metal antimony, and prepared and examined many compounds of that metal. He made green vitriol from pyrites, brandy from fermented grape juice, fulminating gold, sulphide of potash, and spirits of salt. He made and used baths of artificial mineral waters, and he prepared various metals by what are now called wet methods, for instance copper, by immersing plates of iron in solutions of bluestone. He examined the air of mines, and suggested practical methods for determining whether the air in a mine was respirable. Oefer draws attention to a remarkable observation recorded by this alchemist. Speaking of the spirit of mercury, Basil Valentine says it is the origin of all the metals. That spirit is nothing else than an air flying here and there without wings. It is a moving wind, which after it has been chased from its home of Vulcan, that is, fire, returns to the chaos. Then it expands and passes into the region of the air, from whence it had come. As Oefer remarks, this is perhaps one of the earliest accounts of the gas discovered by Priestley, and studied by Lavoisier, the gas we now call oxygen, and recognise as of paramount importance in chemical reactions. Besides discovering and recording many facts which have become part and parcel of the science of chemistry, the alchemists invented and used various pieces of apparatus, and conducted many operations, which are still employed in chemical laboratories. I shall reproduce illustrations of some of these processes and pieces of apparatus, and quote a few of the directions given in a book published in 1664, called The Art of Distillation, by John French, Doctor in Physic. The method recommended by French for hermetically sealing the neck of a glass vessel is shown in Fig. 6. The neck of the vessel is surrounded by a tray containing burning coals. When the glass melts, it is cut off by shears, then closed by tongs, which are made hot before use. Fig. 7 represents a method for covering an open vessel, airtight, with a receptacle into which a substance may be sublimed from the lower vessel. The lettering explains the method of using the apparatus. French gives very practical directions and much sound advice for conducting distillations of various kinds. The following are specimens of his directions and advice. When you put water into a seething balneum wherein there are glasses, let it be hot, or else thou will endanger the breaking of the glasses. When thou takest any earthen or glass vessel from the fire, expose it not to the cold air too suddenly, for fear it should break. In all your operations diligently observe the processes which you read, and vary not a little from them, for sometimes a small mistake or neglect spoils the whole operation, and frustrates your expectations. Try not at first experiments of great cost or great difficulty, for it will be a great discouragement to thee, and thou wilt be very apt to mistake. If any one would enter upon the practices of chemistry, let him apply himself to some expert artist for to be instructed in the manual operation of things, for by this means he will learn more in 2 months than he can by his practice and study in 7 years, as also avoid much pains and cost, and redeem much time, which else of necessity he will lose. Fig. 8 represents a common cold still, and Fig. 9 is a sketch of an apparatus for distilling by the aid of boiling water. The bath wherein the vessels are placed in Fig. 9 was called by the alchemists Balneum Mariae, from Mary the Jewess, who is mentioned in the older alchemical writings, and is supposed to have invented an apparatus of this character. Nothing definite is known of Mary the Jewess. A writer of the 7th century says she was initiated in the sacred art in the temple of Memphis. A legend prevailed among some of the alchemists that she was the sister of Moses. Fig. 10 represents methods of distilling with an apparatus for cooling the volatile products. The lower vessel is an alembic with a long neck, the upper part of which passes through a vessel containing cold water. Fig. 11 shows a pelican, that is, a vessel wherein a liquid might be heated for a long time, and the volatile products be constantly returned to the original vessel. Fig. 12 represents a retort with a receiver. Some of the pieces of apparatus for distilling, which are described by French, are shown in the following figures. Besides describing apparatus for distilling, subliming, and other processes in the laboratory, French gives directions for making tinctures, essences, essential oils, spirits of salt, and pure saltpetre, oil of vitriol, butter of antimony, calces, or as we now say oxides, of metals, and many other substances. He describes processes for making fresh water from salt, artificial mineral water, medicated hot baths for invalids. Note: one of the figures represents an apparatus very like those advertised today as Turkish baths at home. End note. And artificial precious stones. He tells how to test minerals and make alloys, and describes the preparation of many substances made from gold and silver. He also gives many curious receipts. For instance, to make fir trees appear in turpentine, to make a plant grow in 2 or 3 hours, to make the representation of the whole world in a glass, to extract a white milky substance from the rays of the moon. The process of making oil of vitriol by burning sulphur under a hood fitted with a side tube for the outflow of the oil of vitriol is represented in Fig. 13. Fig. 14 is interesting. It is an apparatus for rectifying spirits by distilling, and liquefying only the most volatile portions of the distillate. The spirituous liquor was heated, and the vapours caused to traverse a long zigzag tube, wherein the less volatile portions condensed to liquid, which flowed back into the vessel. The vapour then passed into another vessel, and then through a second zigzag tube, and was finally cooled by water, and the condensed liquid collected. This apparatus was the forerunner of that used to-day for effecting the separation of liquids which boil at different temperatures, by the process called fractional distillation. We should never forget that the alchemists were patient and laborious workers. Their theories were vitally connected with their practice, and there was a constant action and reaction between their general scheme of things and many branches of what we now call chemical manufactures. We may laugh at many of their theories, and regret that much useless material was accumulated by them. We may agree with Boyle at the end of the 17th century, when he likens the Hermetic philosophers, in their search for truth, to the navigators of Solomon's Tarshish fleet, who brought home from their long and tedious voyages not only gold and silver and ivory, but apes and peacocks too. For so the writings of several of your Hermetic philosophers present us, together with divers substantial and noble experiments, theories which either like peacock's feathers make a great show, but are neither solid nor useful, or else like apes, if they have some appearance of being rational, are blemished with some absurdity or other, that, when they are attentively considered, makes them appear ridiculous. But however we may condemn their method, because it rested on their own conception of what the order of nature must be, we cannot but praise their assiduity in conducting experiments and gathering facts. As Bacon says in De Augmentis Scientiarum, alchemy may be compared to the man who told his sons that he had left them gold buried somewhere in his vineyard, where they by digging found no gold, but by turning up the mould about the roots of the vines procured a plentiful vintage. So the search and endeavours to make gold have brought many useful inventions and instructive experiments to light. End of chapter 6.